So just very briefly, guys, there's a list of up-and-coming demo sessions, special interest groups, chapter meetings, and others. All of that information is available on Meetup and on LinkedIn. And so, as Howard said, this is the first collaboration session between ourselves and CTML, which obviously is different to the Cape Town Fish Company, but that is fine. I've shared the links for the meetups for CTML as well as their LinkedIn pages. Thembani, do you want to talk a little bit about what you guys do, how you came about getting going, and if you see any opportunity for further collaboration with us? And then Mishima, if you wanted to chip in at all, just on your thoughts. Otherwise, let's dive in. So maybe Mishima, quickly give us your input on this, being the data scientist man on our committee, and then let's let Thembani get going.
Sure, Drew. Thanks, everyone. And Thembani, we're really looking forward to this session. Twitter was down over the weekend and sometime earlier last week. And in my head, I'm like, Thembani's probably downloading all the tweets. So we're very excited. And we're really looking forward to this. And guys, if you will be bringing in more exciting topics like this in the next sessions, and please do join us. And we will really looking forward to the collaboration with Thembani and team. Yeah, I think I'll just hand over to Thembani.
Thembani, if you want to grab the screen and tell us about CTML and what you guys do, and then let's dive into this, what proposes to be a really, really good topic. Anybody else, have you got any questions at any time, either raise your hand or just type in the chat, and we'll take it from there.
Cheers, thanks, Howard and Shimo. I mean, look, CTML, Cape Town Machine Learning, started a couple of years ago. Actually, I think Tuso and one or two other guys founded the group, and it's always been about creating a space for data professionals, machine learning, data science enthusiasts to be able to connect and share. And so we've always been very sort of open and inclusive, from students all the way into industry and academics doing advanced degrees. We like to get people together to share what they're doing, what they're working on. And this year, we really are trying to push more towards collaborating with other meetups. There are a lot of meetups all over South Africa in and around the data space. And we think one of the things is that we're all a little bit fragmented and separate, and it would be nice to bring all of those communities together, because I think together we're probably a lot more effective. Like you've said, we're available on Meetup, we're available on LinkedIn, wherever, and we're very, very open. And anyone who wants, to discuss something in the broader machine learning or deep learning or data science space, would be welcome to come in and join us. I did my first talk at Cape Town Machine Learning a few years ago about sentiment classification, and this talk will focus a little bit more on topic modeling. I didn't know how technical or non-technical the audience would be, so the talk is mostly non-technical. It's actually a personal little adventure of mine. So a couple of years ago, I started collecting some Twitter data. Specifically, actually, I think I wanted to collect market data to do some exploration about automated trading strategies, and I kind of ended up forgetting about it. And then we discovered this data that I had running on a VM on Google Cloud Platform a couple of months ago, in the middle of a conversation I was having with another collaborator of mine. And so I thought, this data could be of a bit of use, and I wanted to take a closer look at it. And so this is a story of how I got there and sort of where I am at this point in time. If people are interested in where this analysis is going, I'm very keen to do a second talk that continues this conversation and continues the analysis. I mean, I don't know if anyone wants to poke and prod and ask any questions at this point in time, or if people are keen for me to slide straight into the presentation.
Thembani, I will monitor the chat and the participants, and I'll just queue them up as soon as there's a good opportunity.
Okay, cool. I appreciate that. Okay, so this talk, topic modeling on Twitter data comparison, it's a slight comparison because I apply two different topic modeling approaches. and sort of briefly discuss one or two interesting things that I found there. So the talk itself is divided into three major parts. The first part is actually getting a hold of the Twitter data and how I did that. So I very briefly discuss the key aspects of the Twitter API that I used, and then I show you the scraper that I used at the time as well. Then I get into a bit of exploratory data analysis. So, because I've just been scraping this data, I had to apply myself a little bit to thinking about how was I going to structure the data for the purposes of an exercise of this nature, and how was I going to approach things. And then finally, I do a bit of topic modeling. So I looked at latent allocation, which is a popular topic modeling approach, a somewhat traditional one. And then I looked at some embedding-based approaches as well. So that's a rough outline of what's going to happen. So pulling the Twitter data. So a while ago, about, I forget when, I think it was like late 2019, I created a series of lists on Twitter to essentially follow people that I didn't want to follow. I think things have changed, and this is the new description that Twitter gives their list. They say a Twitter list allows you to customize, organize, and prioritize the tweets you see in your timeline. I actually used it to follow people that I didn't want to follow. So the great thing about a list is you can add a variety of members to the list, 5 or 6 people, maybe deplorable people, and that list essentially follows them. And then you can sort of open up that list and you can see kind of what they're talking about, but they won't necessarily appear on your main, won't appear on your main, on your main wall. Sorry? Your main feed. Yes, your main feed, your timeline. So you can see here on the left, these are my lists, of which I've got many now. And on the right, that's kind of how they appear. So you'll see now, actually, when you have a list, people now appear on that list, which means things have become a bit counterproductive. But I just wanted to give you a very broad sense of what this actually looks like on Twitter itself. So I had these lists, and I wanted to essentially create a curated list of people to follow. And I wanted to be able to then pull tweets from that list. So if I wanted to have a bunch of news or market publications or something like this, I could just use the list. And I prefer this approach to using the Twitter API in other ways, like conducting search or whatever, because you're not always sure what you're going to get. I wanted to get information from specific people. Getting a question from Drew, can you filter on topics? Is that the same as a list? Not really, depends on what you mean by that. But a list has individuals, it has handles that you're following. And so then you get everything that handle essentially tweets, every status from that handle. You don't necessarily get just the statuses that are about certain things. For you to get that, you'd have to use the search API. And the reason I didn't want to use the search API is because the challenge of the search API is you never really know what you're going to get, because it gives you sort of a small window of content and you can page through it. But if you want to know what Jacob Zuma is saying, for instance, you wouldn't be able to get that. A topic could be like Cape Town fires. Yeah, so you could search a term like Cape Town fires using the search API. You could also search for hashtags as well. I think there's one called CT fire and there's one called Cape Town fires hashtag. You can get those as well. And I think if you're using the search API, you can also search by geographic region, right? So you can just pull everything that's happening in Cape Town or everything that's happening in South Africa. But the point is, there's a lot of stuff happening. So then how do you get down to the bottom of what you really want? You need to sort of use some very sophisticated keywords and then a bunch of things. But I had experimented with this and I just found it to be a bit unsatisfactory. But also in particular, I wanted to collect everything that MoneyWeb was saying, everything that Business Day Live was saying, for instance. And I think using a list is better, because otherwise you have to page through all of the different accounts. The other advantage of a list is that you can create your list, in your account to the level of depth that you want. So if you're just pulling people from the list, you can add and remove, et cetera, et cetera, et cetera. And so I found that to be convenient. And so here at the bottom right are the Twitter endpoints that I was interested in using for these purposes. So the first one is the lists endpoint, which allows you to basically make 15 requests per window, per app. And a window here is a 15-minute time window. So these are the rate limits of the API. The members allows you to pull all the people that are followed in the list. Bear in mind that the interesting thing about a Twitter list is that you can also follow the list. So the members of the people who the list follows but a subscriber is the person who follows the list, if that makes sense. So when you create a list, you sort of become a subscriber of the list in modern times, but anybody can follow your list. So I've recently created a list which has 4,000 followers, which is strange because I only have less than 200. And then list statuses is the endpoint that allows you to actually pull the statuses of the tweets themselves. That's quite generous. You can do about 900 of those requests every 15 minutes. I think each request pulls about 20 tweets. So you can get away with a lot, with an incredible amount of, just using the official API. And the final one I showed there, statuses user timeline. Essentially, if there's a specific user interested in the following or collecting their tweets, you can do about 1,500 requests against that person's handle per 15-minute window, which is incredible. And that's free. That's on the free tier of the API. They've also got a premium tier and an enterprise tier if you're doing something a little bit more exotic. So in particular, I used Tweepy, which is essentially just a wrapper, the Twitter API in Python, and it allows you to sort of get away with a few things. So the background here is actually the code that I wrote over a year ago to sort of go about pulling these tweets down. So in the top parts, I do a bunch of authentication things, set date and time, create a holder for the various tweets that I want. And then here, I sort of sleep for about a second while I do a variety of things. The first one is pull down the timeline. And the second one is actually pull the extended tweet, and then finally pull the JSON of that tweet. When I went back recently to look at this, I realized that I made two critical errors. One is I hard-coded which list I wanted. And the problem is Twitter is very inconsistent about which list it actually gives you, or at least the way it orders them. So that didn't work out very well, and you'll see why that doesn't work out in a sec. The other thing is when you actually pull, this actually says timelines, you can't see it, it says timelines. When you pull those timelines, it's actually a request. It actually gives you 20 statuses, which means that this bit here was unnecessary. I only realized that recently. But nevertheless, I've since updated this code, not just to pull one list at a time. So I've since extended this to pull all the lists, all the tweets from all the lists. But at the time, I had this running on a VM, and I still do. I think it runs every about 2 hours, if I'm not mistaken. It runs all of this, pulls all the tweets, saves them in a JSON list, and Bob is pretty much your uncle. So I've got, I don't know how many, I assume at this point, thousands of these JSON files somewhere in a VM. I pulled them down, I consolidated them into one massive JSON object, and then started sort of slowly interrogating what's going on in there. So let me maybe just take you into what some of that exploration looked like. So the first thing I realized about this data set is when you pull a tweet, you don't just get the text, this is what someone said, and you don't just get the text plus the screen name. You actually get a lot of things, right? So you get entities, which are the hashtags, and who's been named in the tweet, and a variety of other things. You get the user object, which gives you the screen name, the ID, which is more consistent than the screen name because people change screen names, and a variety of other details about the user as well. You get location information, city name, and a bunch of other things. Sometimes you get a polygon for where they are, and a variety of other things, including, of course, the date and time of when the tweet was sent, etc. So one of the first things I had to do was essentially break some of this data away, because ultimately you want to create some sort of nicely structured tabular data set. So I broke some of that away. I brought some of the user ID information back. So I had the user's ID and the screen name, but threw away most of the rest of it. And then I brought back some of the location information as well. And then I ended up with this nice little tabular data set. And I use a nice Python package called Sweetviz to perform a bit of exploratory data analysis. I'll just pull that into view to show you my screen. Take that as a yes.
Yes, we can.
Fantastic. So Sweetviz is quite nice. I mean, it shows you every single column in your data. And depending on the data type, it gives you some sort of nice univariate analysis, and also might do some correlation or categorical association type of analysis. So a lot of what is here is maybe not too important, but there are a handful of things that I want to do, sort of get a sense of. So first and foremost, how much data do you have? Sort of useful and good to know. But I was also quite interested just to see, what's the language distribution? So especially for South African data, of which a lot of this is, it's nice to see the language distribution, because oftentimes it will say English, even though it's not, because there's a lot of mixed language. But typically you'll find undefined, which is UND, or you'll find Tagalog, which is actually, I think, Malaysian or Singaporean language, which people in South Africa don't actually speak. And so that's an indication that the language API is off, and that you're probably looking at some other languages or some sort of mixed language. So I tend to look at that. I also wanted to look at this in particular because I'm interested in the text components of the data. So you have about 600,000 rows of data. You only have about 263,000 unique tweets, right? And that's because of what you see on the right here. So you see a lot of people have the same tweets, RT, Joe Biden, et cetera, et cetera. And that's because people can retweet a tweet. And if you retweet someone's tweet, you're producing the same content, even though the data row is different. So the screen name is different, the date and time at which the tweet is produced is different, but the language content is the same. So I was just keen to look at this and see what was happening. So a lot of this tended to be these American guys. Something I wasn't expecting, and I've only just realized now, it's actually part of the Twitter data, is that they tell you what the source of the tweet is. And in particular, you can see that people that use iPhones were, the bulk of the tweeters, followed by Android and a variety of other sources. So I just found this to be actually just a strange little data set that I hadn't anticipated, but it was interesting to see that. I mean, the exact date and time I think is worth ignoring, but I did think it was interesting also to look at who's being replied to in a text data set. And this is interesting because the people that are being replied to are the ones generating the most engagement, right? You can see the top guy, I mean, tweeted almost 5,000 times. So whoever that person is, he clearly generates a lot of really interesting, engaging content. I was also interested in the location data, which is why I added it back in. And I was hoping that a great deal of this data would provide like rich, location information. But unfortunately, it really didn't. Well over 99% of the tweets didn't have location information, and the ones that did were mostly for South Africa. And you can see, PE's leading, followed by Stellenbosch. But I doubt those. I doubt that data is accurate or representative. It seems to say that the bulk of the people are from South Africa, which is fine, and it's probably true. But given how small populated it is, it's probably not of value. The other thing I was quite interested in is seeing who's actually doing the bulk of the tweeting. And here you can see it's a lot of the publications, BD Live SA, Fortune Magazine, so on and so forth, who did the majority of the stuff. And then of course the various accounts drop quite a bit. And obviously I also wanted to look at how much data I was actually collecting on a weekly basis, and that was about 7,000-ish tweets. So this gave me like a broad sense of what was happening in the data. Because you can see who's replying to who, you can build a graph and sort of look at relationships. There's a decent amount of text data, unique text data, 263,000 unique documents, as it were. So there's some interesting, nice NLP stuff you can do in a variety of things. So that was quite encouraging. But as you can imagine, this has been an iterative process. I've gone sort of backwards and forwards quite a few times. And one of the things that I did somewhere in the middle of the process is I said, well, the way I pulled the data down the first time didn't give me access to the list that I was pulling. And given who's tweeting and the factors I've looked at, I wanted to attach back the lists that I was looking at. And ultimately, when I did that, I realized that looking at the ML tweets was probably a good idea. And I'll give you a sense of that in a sec about the distribution. So I looked over time, all the way from May 2019 until March 2021. And I looked at which tweets belong to which list. And so this is this hard coding problem that I was referring to. So you can see early on, up until pretty much January 2020, it was mostly market and news data. And then for most of 2020, it was fees data, which was a bunch of fees was fall type activists. And then as of 2021, it was network science for a little while, and then closely followed by machine learning, NLP, and NLP. So originally I'd taken this full data set, applied some LDA to it, applied some BERT topic to it, and the BERT topic sort of fell apart. Once you get above 30,000 or so documents, it really starts to struggle. The LDA takes a while, but again, because you've got like this large mix of fairly different things, and it starts to fall apart. So focusing a little bit more specifically on a domain seemed like a really good idea. And because I hadn't actually looked at these lists, I'd followed them, but I hadn't really bothered to investigate. I thought the ML ones would be kind of interesting, and I thought they'd probably be very familiar to the audience. So that's something I wanted to kind of focus on. And I thought there was a nice amount of data, but not too anything too crazy. And it was also quite recent. So I did the LDA. That gave me a sense of what was happening in the data, and I also sort of selected an interesting piece of the data. But one of the things that was interesting is how do you select the problem to sort of pursue, right? Because the data has lots of implied problems built into it. Topic modeling is kind of a nice, obvious, easy one, but some of the suggestions I got when asking a few colleagues and friends was around creating data sets, right? Creating a large open data set that you can enrich with information from Wikipedia and other sources to make it interesting and useful for people to use for secondary and tertiary tasks. Creating a nice essay colloquialism data set. So especially the feed data that I collected throughout 2020, lots of really good mixed language in there, lots of colloquialism, lots of language you otherwise wouldn't get from some international academic data set. That could be useful. And then of course, comparing the RAND value to Twitter sentiment. So the sort of the markets data from 2019, you've got several months of data, you can compare that. Of course, that's no longer very timely, but that's a type of analysis you can do. And then, of course, community detection, which is looking at who's talking to who and breaking that apart and trying to understand what was happening in those groups. I ultimately went for topic modeling because I think one of the first things you want to do when you're exploring a data set is just know what the data is about. And knowing that the domain is news, or the domain is markets, or the domain is NLP, doesn't necessarily tell you what is happening inside the data. But topic modeling promises that. So it seemed like a good place to go, and it seemed like a nice, a time to stick one's teeth back into this idea. So ultimately, you want to know what topics are being discussed and how they're distributed at the very highest level. But I would say that this hides a lot of complexity, and I'll show some of this when we get around to the results. So we've selected topic modeling as an area of interest. So the obvious question is what is topic modeling? So topic modeling is an unsupervised machine learning technique that's capable of scanning a set of documents, detecting words and phrase patterns within them, and automatically clustering word groups and similar expressions that best characterize a set of documents. This is from Monkey Learn. So I think this is more of an ambition than a description, right? Topic modeling can do a lot for you automatically. The bulk of the work, the analysis still resides with the analyst. I'll show you a little bit of that in a sec as well. So there's two topic modeling approaches that I went for. One was latent allocation, which I'll discuss now. And the next one is a bird topic or an embedding-based topic modeling approach. So latent allocation was devised by three gentlemen: David Blair, Andrew Ng, and Michael Jordan. Not this Michael Jordan, of course, but the academic. And the idea of topic modeling is that it essentially assumes that you've got a document, and that document is a bag of words. And what you do when you create the document is you decide that this document will contain words that will be pulled from some distribution of topics. And in this case, let's say there's two topics in particular, fruits and drinks. And then you essentially pull words out of fruits and drinks and you drop them into your documents. And then you kind of assume away the complexity of all the syntax that arrives at a meaningful sentence. So this is roughly what we're estimating. And what we assume in LDA is that that number of topics is known up front. So you tell it about 4 topics, and it will automatically identify how it is that those 4 topics came to form all of these different documents. And then depending on the level of sophistication, you can then look at the topics within the document, and you can say 20% of this document is this topic and that topic and this other topic, and you can then take the one that's the maximum, and you can assign your document to that topic. So actually implementing LDA is fairly straightforward. There's a package in GenSim called LDA, if I'm not mistaken. There are a number of traditional, because it's a traditional method, there are a number of traditional that you want to take. So you want to eliminate some stop words. In this case, I removed RT and HTTPS and HTTP, which are traditional sort of Twitter stop words. I used a trigram language model. So I used groups of words from 1 to 2 to 3, and then I removed any word that appeared less than 3 times. This was a fairly sort of standard implementation. I used default parameters of the model, and then I arbitrarily selected 10 topics and then assigned 1 topic to every single document. So selecting 10 topics in an LDA context tends to be a very controversial choice. And it's something which I think topic modeling practitioners try to spend a lot of time trying to resolve. And there's 2 ways to try and resolve this, right? How do you establish the right number of topics? The traditional method is to apply a method called perplexity, or to extract a perplexity measure, which looks at the, I think it's the normalized log likelihood of your LDA model on unseen data. And while that's sort of a rational thing to do, the challenge is it typically doesn't correlate with what people consider to be coherent topics. As a matter of fact, people say that it's actually slightly negatively correlated. And so there's this coherence framework which looks at a variety of measures that try to look at the top coefficients for your topic modeling approach, and then see if those are consistent with each other, or if they're rational in some way. And this is sort of like the preferred approach. Yeah, so I sort of shy away from sort of any approach that tries to give you the right number of topics, because I think that in establishing the right number of topics, there's probably a lot of domain knowledge that goes into it. And so, if LDA says that there's 4 topics and there should be 12, you still have to do some work to establish where those 12 topics are, regardless of what your complexity or coherence measures may say. So my bias in this case is to pick some arbitrary, reasonable number of topics, investigate them, and then maybe do some of this additional parameterization, additional optimization.
Sorry, Thembani.
Yes.
There's just a question from JG to say, I think you've answered 2 of them, but one question is there a constraint on the number of topics that's supported by LDA?
That's an interesting question. Not that I know of explicitly. I've never been in a situation where I've produced too many topics. Let me put it that way. I think in theory, you probably couldn't produce more topics than you have unique words, because that probably just wouldn't be able to work. Just beyond that, I'm not sure if there are specific constraints.
All right, and I think you've answered the other 2. Just to make sure from JG is, how can you be sure of the topic count? How dependent is this? And I'm assuming that's what you spoke about on the last screen in terms of perplexity and those counts, just trying to ensure that you've got the right mix of topics.
Yeah, so sorry, when he says the topic count, he means the number of topics. Is that?
Yes, correct.
Yeah, so I think what you'll see by the time we get to the end of this talk is that is the question.
Yeah.
So to speak, that is the answer to all things, which is how many topics are there, and that depends a lot more on your domain than it does on any algorithm. No algorithm can give you that answer, if that makes sense.
Yep, and it's not 42.
It could be. It could very well be. But that's a good point that you touch on, which is that the part of the reason why I focused just on the ML side is because when you look at the full data set, the news, the markets, the fees, the network science, etc., you may very well find that each one has 5 or 10 topics within it, right? And so then when you're performing LDA across all of them, or you're performing any kind of topic modeling across all of them, you're actually looking at all those different topics, right? And it becomes a larger and larger number, and it becomes more and more unwieldy. Right. If you look at each one individually, you can probably establish these things a lot more clearly.
Yeah.
Excuse me. So the embedding-based topic modeling approaches. Now, part of the reason why I was interested in doing topic modeling is precisely because this idea cropped up sort of recently, I think like a year-ish or so ago. Somebody brought this to my attention. They said, well, typically with all these different topic modeling approaches, you sort of have to create some sort of complex algorithm to represent your data in a TF in a term frequency matrix, and then you apply some sophisticated linear algebra and you get an answer. But there was, I think it was in 2010, Thomas Mikolov I showed the world that you can actually embed words in high dimensional space, right? And you can perform linear algebra on those words, right? So you can add, you can take a word like king, you can subtract man from it, you can add woman to it, and then you get, a vector that looks like queen, for instance. And this was like an interesting idea. And I remember at the time, we were exploring exactly this kind of idea. We were saying, we pull Twitter data and we do some stuff to it. Can we extract like meaningful, interesting things? And one of the things we wanted to do as part of our keyword search was eliminate keyword search altogether and use semantic search, embedding-based search. And part of the problem with doing that with word vectors is that when you take a tweet, you take any document, and you have a series of word vectors. When you arbitrarily combine those word vectors, or you average them, or anything like this, you typically lose a lot of meaning, right? And it usually averages out to something not useful. And so this new idea has recently emerged where you can actually embed sentences. So I think one of the salient ideas here was around universal sentence encoding, right? So you're no longer dealing with something where you take a known word and you embed that known word, like king or queen or whatever. You can take an arbitrary sentence and embed that sentence in high dimensional space, and then you get all the benefits of high dimensional space. The key, the main one is being able to apply linear algebra to that sentence. So your embedding-based topic modeling approach directly benefits from this. So you're able to take all your documents, in this case, all of our tweets. We're able to embed them in high dimensional space. And once they're there, we're able to apply really any kind of clustering technique we care for, whether it's k-means or anything else. And what that should naturally do is bring together documents that relate to or about the same thing. The challenge, of course, is that when you have a high dimensional space, 100 dimensions, 300 dimensions, what have you, your clustering methods might struggle. And so one of the things you might want to do is apply some sort of dimensionality reduction, bring down the dimensions, and then sort of go from there. And then now you have topics. And there might obviously be a natural question around how do you then extract coefficients, because typically you need some sort of coefficients to tell you what are the most impactful, important words that define a cluster. But before I answer that, I just want to introduce BERT topic. So BERT topic is a way of doing this. BERT is if I remember correctly, a bidirectional, the question, it's a bidirectional transformer approach to building large-scale language models. I think it was released by the guys at Google, I think just before New York 2019. So I think, I don't know, sometime in 2019, if I'm not mistaken. And so what's particularly interesting about these language models is that they built them on massive amounts of data. And they built them on a handful of tasks. I forget the specific one that BERT was trained on, but I think the two main ways that people build language models is either to build masked language models where you sort of hide some of the words and then the model has to predict which word is which, or you sort of predict just the next word and then it sort of learns all kinds of interesting things about the language, that is. What's great about these models is that they were built as high-level models that could then be adapted to low-level tasks. And so the nice thing is some good people have done this for us. They've taken these models and they've adapted them to the purpose of just being able to take a sentence and embed it in high-dimensional space. The other great thing is that because BERT has a lot of different implementations and ideas, there are a lot of versions of BERT that have been trained for a variety of different languages, especially low-resource languages like our South African languages, like Xhosa, isiZulu, a variety of others. So in the model that we use in particular here has English and Afrikaans and Xhosa built into the language model. So in a previous iteration, when I was clustering the entire data set, it was actually able to extract one or two clusters or one or two topics that were specifically focused around people speaking in Xhosa. So that sort of bodes well for future applications. So I use this model to embed these ML tweets in high-dimensional space, or at least BERT topic did this for me. And then first of all, started out by implementing a nice dimensionality reduction method called UMAP. which is able to take this high dimensional sentence vector and bring it down to about, if I remember correctly, 5 dimensions. The advantage, and I think some of you may know about t-SNE. I think it's a t-distributed neighbor, nearest neighbor embedding, which was a very popular method for creating beautiful sort of 2D representations of high dimensional data. And I think people applied it oftentimes to word embeddings. But the challenge is that it loses global context. It may retain local context, but it loses global context, whereas UMAP is able to maintain global context even while you're reducing dimensions. I don't think that matters too much in our case because we're actually interested in the local structure, which is where the topic should exist. But nevertheless, it is the new kid on the block. And DBSCAN, I think, is quite an old clustering method that essentially allows you to cluster data without having to provide the number of clusters that you want. You can simply provide a sense of how close elements need to be, or how close observations need to be, and how many observations would determine a region of interest or a density. And then on that basis, it's able to automatically detect outliers and a variety of things, create clusters for you, and then say, you've got 20 clusters, which has its pros and cons. Yes. So now for the interesting bit. So I'm just going to show you, sort of what has come out, just the distribution of the topics, some words and coefficients, in particular for 2 topics that I find quite interesting, and the top tweets. And hopefully soon after that, we'll wrap up. So the first thing I really wanted to show you is that we've got bird topic on the right and LDA bird topic on the left and LDA on the right. You'll notice that with bird topic, there's a very big -1 class. There's actually 11 classes on the bird topic side. And -1 is what I would refer to as the junk class. And I think this is a direct consequence of the way that DBSCAN works. I think a lot of tuning is probably required there to be able to get that down so that you sort of are able to get a few more salient clusters. It introduces some level of complexity in every variation of bird topic that I ran. About 50% of the data would end up in the junk topic, which I would argue is probably too much, given how concentrated at this point the ML tweets data is. If it is the broad data set, it would make more sense. But given that it's just the ML data set, I would imagine that -1 is well overblown. And on the right-hand side, you can see we've got a much more uniform sort of distribution of topics. Similarly, I think that's probably a little bit unnatural as well. I wouldn't expect them to have that nice little beautiful shape. But again, it's because we haven't really focused too much on optimizing these things. We've rather focused on extracting them, looking at them, and then using that as an iteration process. And if you're a bit alarmed by the sort of large numbers representing the topics on the bird topic side, the bird topic actually naturally generates quite a large number of topics. And the way you bring it to 10 is it periodically sort of joins them back up again into these just 10 topics. Because 10 was by arbitrarily selected number of topics. So there's 2 topics that I found particularly interesting in each topic modeling approach. On the bird topic side, I found 221, this topic here, to be of interest. And on the LDA side, I found topic 3 to be a bit interesting. And so I'll take you into each of them, and we can sort of discuss what's going on there. So with bird topic, on the right, what you'll see is actually the same word cloud. So I just took essentially all the documents from that topic, and I produced a word cloud, and the one on the bottom shows you the more right-hand side of the word cloud, and one on the top shows you the more left-hand side of the word cloud. Please don't judge me for this choice. It just looked like a nice little PowerPoint template, and I decided to embrace it fully. And on the left, you'll see a table which shows the coefficients that represent the specific topic. And so when I looked at this, and this is using the ML tweets data set from March, when I looked at it, it just seemed a bit interesting because there's a lot of talk about happiness and comic books and pineapple cake and eating pineapples, and I just thought, what on earth is going on here? When I look at the coefficients, pineapple is the strongest term. And then there's, discussion about Jan LeCun. So I don't know, maybe Jan LeCun has a new sort of pineapple recipe that he's cooking up. Maybe this is a new sort of language model or some work that's happening at Facebook or something. I don't know. But it just seemed strange. and I wanted to investigate it a little bit more deeply. And when I actually went looking for the actual tweets that represented or came out of this, one of the things you can actually just do is you can just take the coefficients and you can just apply them to all the tweets and you can rank the tweets. And the top tweets that came out were these ones, right? And if you look at this top tweet here on the right, it says, I think my happiness is reading comics, drinking good tea and having pineapple cakes, right? And that was actually tweeted by Taryn Klanuwat, who's this person here, TK Sasagi. She's actually a computer vision and NLP practitioner that focuses a lot on, I think, sort of computer vision around Japanese characters. What was weird and interesting about this is that, she's obviously a relevant member of the machine learning community, but this particular topic arose because she submitted, a paper or some work or something, and between about the 5th and the 15th of March, she just, kept talking a lot about pineapple cake, and actually generated a bit of engagement, right? So a bunch of people started talking about pineapple cake and so on and so forth. So this was actually a full-on topic, specifically around pineapple cakes that had arisen within the ML community. And what's interesting about this is that even though it's unexpected, because you wouldn't expect pineapple cakes to be a typical topic of discussion in the ML community, it's still nevertheless relevant, right? If your question was, what were the things that people were discussing? What are the 10 things people were discussing? You would probably highlight this as something that people were discussing. You just probably wouldn't attach much academic or technical value to the discussion. And then the other tweets, speak to the talk that Jan LeCun is doing as part of Answers AI, that someone congratulated him for, and then a lot of engagement was created around that. Another topic around David Sontag's ML and healthcare course, which I actually had a brief look at, and actually looks incredibly compelling, and quite a few people are interested in that. What you'll notice is that these three things probably don't relate to each other as much as they should, and so that probably speaks to joining these topics up in a variety of ways, something like that. But I'd also say that what's maybe hidden and not apparent is that very likely the great majority of people in this topic are speaking towards what Taryn is talking about, not these other topics. So what this demonstrates to me is one of the really powerful aspects of topic modeling, which is that even though you're topic modeling in a domain that you know and understand, there's always opportunity to discover things that are serendipitous, right? And this is one such topic. The other topic I found interesting was topic 3 in LDA. So when you look at this topic, and you look at the word clouds on the right, you see sweet spot and you see language modeling, natural language coming up quite a bit, et cetera, I think literature also comes up. And when you look at the coefficients of the words, you see model and you see language. And so naturally you think, well, this has a lot to do with language modeling, which would be like a nice obvious conclusion. So if you didn't sort of look any more into it, you'd say, well, this is a topic broadly around language modeling, and somebody thinks language modeling is a sweet spot or something like this. When you actually look at the top tweets within this topic, you realize that Miles Brundage actually started an entire thread where he was talking about topic modeling. Where he was talking about language modeling. And one of the things that he touched on sort of briefly is that, in fact, his thread was about AI ethics and AI policy. And one of the things that he was trying to say, if I paraphrase him correctly, is that one of the challenges in AI policy and AI ethics is that there are a number of big companies who, like Google, et cetera, who directly benefit from the direction that research goes in, and who probably don't want too much for some of those sort of negative consequences of the work that they do to be highlighted, right? And so, I mean, he had an incredibly long thread, I think easily 20-ish tweets, and generated a bit of engagement. The point being that this topic is about language modeling, but it's actually a lot more about AI policy and AI ethics than it is about language modeling per se. Language modeling is just the region within which AI ethics and AI policies happens. And so really this topic speaks to a different dynamic in topic modeling, which is that just because the coefficients and the resulting word cloud look a particular way, so to speak, doesn't mean that you've actually identified what the topic is. Right? The way you identify what a topic is to have sort of a depth of understanding of the domain and to investigate some of the actual underlying documents. And that gives you a much, much clearer sense of what you're doing. So in other words, the analysis work still has to happen. And something I notice a lot in the sort of articles from towards data science that I used to get here is that oftentimes people find it sufficient to say, here are the coefficients, here's like a very consistent looking word cloud, let's all go home. And as a matter of fact, the coherence measure for LDA kind of says a similar kind of thing. Well, the top sort of terms look pretty similar, let's all go home. However, in order to make the topic actionable, in order to actually use it, you actually need to have a real sense of what's happening in that topic. And so the purpose of topic modeling is not to generate these coefficients and to generate these word clouds, but rather to generate the story, the explanation of what is it exactly within meaningful context that's happening within this topic, within this broader domain. And so I just want to leave you with this thought that I've been reflecting on slightly. So I mean, we've gone through collecting the data set with Tweepy, structuring the data set for a particular problem, selecting the ML tweets, performing LDA using these two methods, and highlighting serendipity and how words and coefficients can be misleading with these two topics. But the picture that you see here in the background is actually a picture from some analysis that a collaborator of mine did, Phaweni. He focuses a lot on community detection on Twitter, and he focuses a lot in the domain of South African politics, not just global politics. And what he likes to do is to try and understand how many people are discussing, are talking to each other rather. And he defines, who these people are based on who the top contributors are. But the story that's told ultimately doesn't really come from knowing that this is Thembani and some of his guys, and knowing that this is Ramaphosa, etc. The story actually comes from all the political news that happens leading up to the point of analysis. In other words, depth of understanding of the domain. That's where the real value comes from. The analysis, the topic modeling, the clustering, which he does here, the community detection, allows you to put that domain knowledge into additional context. It allows you to quantify, it allows you to identify where and when some of these things were happening naturally in a place like Twitter. Bear in mind that he doesn't actually read thousands of tweets, sometimes millions of tweets that he uses to produce this analysis. But because of all the political coverage that's happening, it's pretty clear based on looking at who's talking and when, what the underlying discussion is. So the thought I wanted to give you is at this point, what I've established is I've done some topic modeling. I've established that there's some interesting trends. And what I need to sort of go on and do now is dig a lot deeper into what was actually happening in the ML community on Twitter throughout, sort of the first half of March. And on that basis, what I'll be able to do then is take this information and contextualize it and ultimately tell a story. So if you're interested in that, please let me know, and then we can set up part 2 at CTML, hopefully not this month, probably next month. And we can come back and I can dive a little bit deeper into the conversation. That's where I'd like to leave it. If there are any questions or thoughts, very happy to receive them.
Yeah, Thembani, thanks very much. I think it's a very interesting topic that you've brought up, and that's almost that search for meaning is something that we have to pay attention to. So the original graphs and figures can be quite misleading, that visualization, until you dig into the meaning. And I was interested in almost the word versus semantics. Have you? So you've displayed a lot of words, but is the meaning and what are they talking about more at a meaning level, at a semantic level than the word level? So, and I know doing textual and analytics with quite a few people in terms of studying it, one of the things they say right in the beginning is just looking at the word and a taxonomy of the words is not helpful to understand the meanings, and you seem to have pointed that out. Yeah,
and I mean that's so the almost the irony, if you will, is that part of what these embedding-based approaches help us to do is to find things that are consistent in terms of meaning, right? So you find documents that are very close to each other, terms of meaning, but it's one thing for the documents to be internally consistent. It's another thing to communicate that to a third party in a way which is consistent with the underlying message within that broader conversation.
Mm. Yeah, the area that I looked at, or there was a class on by Bill Inman, is a lot of the analysis of call centers and people getting an understanding of not just how many people are phoning to complain in terms of simplistic sentiment and tonality, but what are they complaining about? And is it a product that I have a defect, or what is the issue? And it's that constant searching for the right meaning and the right understanding, rather than just explaining a numeric count of the words.
Yeah, and so I think part of the idea is to simply say that's probably an approach you should move away from, right? You should probably sort of remember that a big part of data science is actually analysis. So performing the method is great and tells you where to go look, but you still need to go look and have confidence around those inferences. I see there's two questions from Carl and from Debalo. So I think the first question from Carl is, does tweets have different semantics than natural language? Which is a difficult question to answer, but I think the simple answer is probably depends on what you mean by natural language. But I think the answer you're looking for there is yes, and we can sort of have a look. So here I think the way that Miles is writing things is the way that people would normally write things. And there's probably not a lot of differences there. But I think if you look here, maybe this doesn't sort of demonstrate it well. But maybe if you look at this tweet by Isabel Rail, there is a bunch of things that will be different about tweets. For instance, you'll keep seeing this RT a lot. You'll see people's handles. You'll see a lot of hashtags, and sometimes you'll see a lot of emojis and other things like this, which I think does introduce a bit of a problem. Also, tweets can only be 140 characters long, right? So, and that becomes apparent in this because people start to create threads. So it starts to actually become very difficult to follow a train of thought. It's not like having an essay where you know that someone is talking about the same thing over a 5-page document. It's more than like that. You get these sporadic things that interact with a lot of people. Carl, I'm not sure if that answers your question, but please let me know if it doesn't. Debala asked, which approach between the two methods would you rely on and why? Look, I think the methods are a bit different. So a big part of this for me is to investigate the embedding-based approaches and to try and understand what they offer above and beyond what something like LDA offers. So it's probably a bit soon for me to answer that question. But what I can say is that something like BERT topic is a lot more intellectually easy to be happy with, if that makes sense, because there are not a lot of black holes in something like BERT, besides the language model itself. It's pretty clear what you're doing and how to go about optimizing it. Whereas something like LDA, you would have to spend a lot of time digging very deep into the math of what LDA does for you to become very, very satisfied that you've implemented it in the best possible way that you could. There's also no benefit from LDA in terms of the fact that every time you run LDA, you're starting from zero and then you're building a topic model. And what that means is that with something like BERT, you have a lot of, or any language modeling approach, you have a lot of language that the model already has or has learned that you're leveraging from, right? So built into it already has sort of knowledge that you can rely on. And I think in the fullness of time, as those models get better and better and learn more and more, a lot of your starting point would have been moved much further along because it has a lot of that beautiful semantic understanding. Debala, I don't know if that answers you, but I would say that I believe that in the fullness of time, the embedding-based approaches will probably be the ones that we actually use. SD has a question.
And Mushima had his hand up.
Yeah, I see Mushima. I'm trying to work my way down. So SD is asking if data from private accounts is not available. As far as I know, direct messages are not available through the Twitter API. And I would imagine that private messages that you send or private tweets would also not be available. the privacy concern issue is a good one, not just private information, but even for public, right? So I think a lot of people up to this point have assumed that just because Twitter data is public, it means you're good to go ahead and analyze it. I think the more modern thought process is that people may not know that people like myself have the ability to collect their tweets, collect them over time, and analyze them over time. So at the moment, it's a little bit of a ethics gray area. But the hard line people would say that if you haven't explicitly asked for and received consent to use the data, you shouldn't use it. And I think most of the people would say, well, it's public, so it is what it is. But I don't know if we're ever going to reach a conclusion about that in any sort of meaningful or definitive way anytime soon. And JG, okay, so JG was just saying that he'd be interested in a second talk. I'd be happy with that. And then Shima, so you get your hand up.
Sure. Thanks for that. Very, very good presentation. I actually enjoyed that. And as you were going through, I was just wondering, so we, in our business, we operate in about 21 markets. And in those 21 markets, we have, multiple languages, Swahili, and Nigeria has, I don't know how many languages that they have, and so on. And one of the things we are often asked by the marketing team is, can you go on Twitter and do like a quick sentiment analysis for us? Now, we often pick a lot of tweets about MTN, but some of them, the languages we don't know. So question number one is, what sort of advice would you give an organization like that to really, is it worthwhile to even do sentiment analysis or that? Or should we build a dictionary based on the common languages that in the markets that we operate in to translate most of the sentiments into English? And then also the last question is, if you look at certain languages, you would find that there are some words that have sort of similar meaning but are spelled differently. And how do you deal with things like that?
So you said words that are spelled differently but have the same meaning.
Yeah, so I'm just thinking like, for example, you would have with words with similar meaning that can exist, but they're spelled differently.
Yeah, so okay, so the promise of especially something like sentence embedding is that things should end up in the same part of your space. So they should be embedded close to each other in vector space. And so if you have someone who says Facebook and someone who says FB, they should be pretty much the same, right? Because they're used in a lot of the same contexts. So that problem should be easy to eliminate. As for multiple languages, it's a bit tricky. And I would steer away, while having a dictionary is a great thing, I would probably steer away from it for a variety of reasons, because first of all, Twitter is highly dynamic and there's a lot of slang on there, et cetera, et cetera. What would probably be a good use of time and energy is to actually build your custom embedding model. So you can take something like BERT, and then you can apply it essentially to all of your tweets, because language modeling is a unstructured, and it's a problem. It's an unsupervised problem. It doesn't need labeled data, right? Because you sort of generate the labels yourself. And so what I would do is I would generate my own sort of word embeddings using my own sort of custom BERT model, so to speak, which covers your Hausas, your Yorubas, your Swahilis, etc. The other thing is I'm pretty sure those languages are covered by some of the more custom versions of BERT, like Roberto and a few others. So I'd probably start there and then build my own custom language model if needs be. And then from that, you can go downstream and build a sentiment model if you really need to. But once you've got the embeddings, you can probably do some powerful clustering and answer a couple of questions. So that'll be, I think, an answer to both of your questions, Shima. Okay, cool. There's another question from Dibalo, who's asking if there's a way to know that one, if there's a way to know if the topics are related to each other. It depends on how you're doing it, right? So what I don't like about applying these ideas with LDA is that with LDA, all you have is the words themselves, and you would have to do some sort of pairwise, something like a Jacquard similarity or something like this. which is useful, but I don't think it's as useful as what you can do with something like BERT, where you can have sort of a collection of embeddings per topic, and then you can actually compare those directly. And that's probably how I'd go about doing it, unless, of course, you've got one centralized topic embedding. But I'm not sure if they take that approach. Debala, that's just an answer to your second question. And then Nkateko, yes. So how do you collect data from a place that doesn't have an API, or is there a specific clause that you would look for in the documentation? Yeah, so this touches on the AI ethics side of things all over again. So one of the things is that we come from a no consent world where, you know, if it's in the public domain, if you know, the people don't have fences, you sort of just go in there and grab it and hope for the best. A lot of companies do have terms of service that tell you what you can and can't do. So I think Twitter specifically says that you're not allowed to scrape their website, even though it's perfectly possible. But I would read the terms of service first and see what they say and what they don't say. And if they don't speak about it in particular, it's probably a good idea to ask questions and just, you know, send them a mail and say, can I pull your data? Yes or no? And then if they have relevant documentation about how you may pull their data, like, so remember, most websites allow Google and other search engines to scrape their data periodically. And they'll typically have something like a text file that says how that's allowed to happen. But again, the permission is typically just for purposes of search, right? So if you want to do it for something else, analysis, what have you, commercial reasons, to cover your bases, it's probably a good idea to just ask them, and then you'll see how it goes. But I mean, back in the day, yeah, if it was online, there are a variety of ways you could just scrape it. You know, Beautiful Soup, Selenium, and there's a number of sort of crawling tools like WebCopy, you know, Bob Janko. Hayden, I don't know what this question is, Hayden.
I think what he's trying to ask is when you have challenging sentences like time flies like an arrow or fruit flies like a banana. So, you know, there's the fruit flies is the one that likes the banana. And so you're getting these words and trying to understand the meaning. And he's asking, is that a language problem?
He's asking, is it a language problem?
Yes.
So yeah, so there are, I think there's research in an area called word sense disambiguation, right? Which is a little bit similar to what's being discussed here. So, you know, he sat on the wall, or whatever, I don't know, something like this, right? And then the question is, like, who's the he? You know, is it the guy sitting on the bench, or is it the guy doing some other stuff? I forget the exact problem setting, but the point is that whenever you have, let's say, pronouns, for instance, you need to identify which of the people might refer to that pronoun. And this is a more subtle version of that, where you're trying to identify or disambiguate what different words mean in different contexts and settings. A lot of these problems are what I consider to be cutting edge NLP. They're not solved, but what I will say is that a lot of the really large scale language models have made a lot of advancements towards solving those models. So a lot of the problems that were quite difficult 5 years ago, what we found is that with large scale language models, with a simple logistic classifier, you can usually get very close to state of the art just because of how much linguistic and semantic meaning a lot of your embeddings have in them. But yeah, I can't really say if this is going to be a solved problem anytime soon.
Martin, does that answer your question?
Yes, pretty much. Thanks.
Okay. Thembani, that the questions seem to have gone quiet. But thank you very much for a really great session. Drew, anything like you'd like to add?
No, for me it was fascinating. It really is interesting to see where this lot is going. And maybe what I'd suggest is our next session is the 17th of May, where we could have a follow-up if Thembani is ready, and between him and Machinimo they can coordinate things.
That would be great.
Sure. Yeah, I think we can chat. We can chat offline.
I think Thembani, you also mentioned earlier on that we may have the second session with the CTML. I think there was some discussion about that, so we can cross-pollinate.
Yes, absolutely.
Yeah. So I mean, we typically host our sessions at about 6 p.m. on a Tuesday. We pick a Tuesday and we go for that. So I think we just have to find like a happy medium.
Right. We can do that, and we can just post to our members that it's the round number 2 will be happening on your side.
Yeah, happy for that. Yeah.
Fantastic.
Oh, but once again, from my side, and from especially to Mishima for organizing, and to the CTML guys that came along, I think it's been great. I think hopefully it's the first of many.
I think Tabala's got his hand up.
I think I've got a question. Thanks very much, guys, and thanks Thembani for the great presentation. So, just a quick one: Have you ever used the knowledge graph, or is that something that you've ever tried to explore? And if so, I mean, I'll be much delighted if you can one day create a presentation around that as well.
Sure. So so I've kind of maybe buried that lead slightly. So when we talk about this topic modeling, we think about it end to end, right? What we're sort of trying to do to some extent, and I think how it raises it slightly, is one of the things that you want to do is you want to establish a domain, and then within that domain you want to slice it up in some sort of nice, meaningful way, and then you want to sort of maybe plug your topics within there somewhere, right? And so the idea of a knowledge graph to some extent is that you can somehow learn in data, you can learn taxonomies, and you can learn ontologies. And ideally, you can then take that knowledge and somehow use it to, like, I would imagine, do your topic modeling end-to-end automatically. There was a guy called Ajit who works at KPI who's been doing a lot of work on knowledge graphs, and I don't think he's solved that question yet. But he's actually meant to be doing a follow-up talk to his original talk where he introduced the idea of knowledge graphs, and he's supposed to be showing us how good they are at sort of dynamically learning these types of relationships. And I guess, Dibala, if you're interested, I would advise sort of going down that road. I myself have not gotten there yet. I'm not really sure. And a big part of it is because the underlying methods are new. So there are these graph convolutional neural nets that they use to sort of like learn these structures, the complexities of which I'm not very comfortable with at the moment. So I think once I've seen these things once or twice, I may look for a time and place to apply them.
Yeah, and I think it's important also from an ontology point of view, and we're seeing that in the banking industry, where they're looking at that combined relationship between people modeling the knowledge graph or the ontology, and then understanding what certain corpuses are confirming with respect to their knowledge graph. So there's this combined semantic understanding to work out how good the knowledge graph is and what people are saying and how truthful it is.
Thanks very much.
Excellent. Guys, thank you very much. Thanks everybody for joining. It's always amazing to see how we're piecing all these bits and coming together and being able to apply it in different ways. Thembani, I know I've got a couple of people that asked to contact you and wanted to talk to you. I don't know if you would like to leave an email address or something else. They can contact you on LinkedIn. How would you prefer they connect with you? Sorry, you're on mute, Thembani.
Howard, I keep saying this, like this is the story of my life. I'm pretty reliable on LinkedIn usually. I will respond even if it's just to tell you that I'm only going to respond later.
Right.
You can find me on Twitter, but I'm pretty useless on Twitter. You can mail me on this email address.
Okay.
I'll probably get back to you. So if it's something fairly serious, maybe just touch me on LinkedIn. I check it sort of every other day or something, and I'll come back to you.
Okay.
Otherwise, you can just pop me a random cold mail, and when the time comes, I'll have a look.
Excellent. Thembani, thank you very much. Mishima, thanks. Drew, thanks everybody. Thanks everybody for coming. I hope you have a wonderful night.
Good one.
Yeah, likewise. Thanks for having us. It's been nice to have the session and sort of talk to all your peeps.
Thanks, man.
Thank you.